Today's lesson will focus on the law of large numbers and what we call the expected value of an event. The law of large numbers says that if you do any activity over and over again, what actually happens approaches what should happen. For instance, if you flip a coin over and over again, the number of heads that you're actually good at getting should be equal to about 50% of those flips, because that's what should happen. The law of large numbers is why Vegas works. Vegas knows that even though some people may win, what should happen as you play more and more and more is that more people are going to lose. So here's an example. A roulette wheel has 38 numbers. 18 are black, 18 red, and the numbers 0 and 00 in green. Assume that all possible outcomes, 38 numbers, have equal probability. So the first question asks, what is the probability of getting a red number on any spin? Well, to get a red number, this is the probability of getting a red number. There are a total of 38 numbers on the board, on the wheel. And out of those 38 numbers, 18 of them are red. So there is a 18 out of 38 chance of doing that, or we can reduce this by a factor of 2. So we get 9 out of 19, which is approximately going to be equal to 0.474. So about a 47% chance that you're going to get a red number there. Now, if patrons in a casino spin the wheel 10,000 times, how many times should you expect a red number? Well, the more we play it, and what this means is that if you play it one time, there's a 47% chance that it should occur. Or basically a 1 in 2 chance almost, 50%. But do you think that you're going to always land on red every other spin? That's what you're literally saying. Probably not. But if you play it 100,000 times, guess what happens? As you look at those spins, the reds and the blacks start to match each other and get really, really close to each other. So all you have to do here is, if we play it 100,000 times, with each spin having a probability 0.474, we just take 0.474 and multiply by 100,000. And that's equal to 47,400 times that you should land on a red number. So this idea of the law of large numbers, which states that as we do something more and more, those actual probabilities, the ones that you actually do when you do the event, is going to approach the theoretical or the what should happen probabilities the more and more you do it. It's going to give leeway to what we call the expected value. And the expected value is basically a mean, the average, is what should happen. And so we use the expected value extensively in statistics and probability in real life when we talk about insurance. When they set premiums for particular policies, your car insurance, your home insurance. So here's an example that says, suppose an automobile insurance company sells an insurance policy with an annual premium of $200. That means it costs people $200 to get that particular policy. Based on data from past claims, the company has calculated the following probabilities. An average of 1 in 50 policyholders will file a claim of $2,000. An average of 1 in 20 policyholders will file a claim of $1,000. And an average of 1 in 10 policyholders will file a claim of $500. So notice, these probabilities that they're associated with these can be written like this. 1 in 50 is equal to 2% of the people file claims of $2,000. 1 in 20, 5% of those people file claims like that of $1,000. And then here, the most common claim that people file are 1 in 10, or 10% of the people file claims of $500. Assuming that the policyholder could file any of the claims above, what is the expected value of the company for each policy sold? Well, it works like this. Every policy sold is $200. So the expected, also known as E of X, is equal to, we expect to make $200, or the company expects to make $200 on every policy that is sold. Therefore, here's what we also know. They're going to lose money if they have to pay out any one of these potential probability policies there. And we can calculate how much money they're going to lose based off the fact that we know the probability of each event and we know how much they're going to lose based off their probability. So we set this up as $200 is made on every policy minus, if we have to pay we pay 2% of the time, we're going to pay $2,000 out. So we're going to take that probability there, 0.02, and we're going to multiply it by by the amount that we're going to pay, which is 2,000, right? Minus, or we can pay 5% multiplied by its probability, or multiplied by its amount that we're paying, which is 1,000, which is what we expect to pay, minus, or we can pay 10% of the time, we're going to pay $500. So what you've done here, this is how much you're expected to lose. This is the expected value to lose. And this is your expected gain. If we put those two things together, we're going to get the expected amount. So here's how we calculate this then. 0.02 times 2,000, this is just $40. Minus 0.05 times 1,000, this is $50. 0.10 times 500, this is also $50. So you can see that on any one policy based off the probabilities, we're going to lose $140. But we're always going to gain, we're always making people pay $200. So the expected is equal to the $200 they have to pay minus the $140 we can lose on any policy. So it looks like our expected gain here, because we're gaining when it's positive, is going to be $60. Now, this may not seem a lot, but it's why insurance works, because this is solely on one policy. Insurance companies have thousands on thousands on thousands, even millions of customers. They're making $60 on every particular customer that has a policy. In that case, if you multiply that over the long run, which is the law of large numbers, it says that in the end, insurance companies will always make money based off of this. Example 2 looks at gambling and lotteries. Suppose that a dollar lottery ticket has the following probabilities and values. 1 in 5 to win a free ticket worth $1. So 20% of the time, you're going to win. 1 in 5 is 20% of the time. 1% of the time, 1 in 100, you win $5. 1 in 100,000, that's equal to 0.00005. And then 1 in a million, that equals 0.0003405. I'm sorry, this one up here should have been 0.001. So this one has 4 zeros, this one has 5 zeros. So notice that the probabilities decrease the higher the expected amount to win increases. So it wants to know, what is the expected value of a lottery ticket then? Well, it costs you $1. So you're going to automatically start off by losing $1. Or we'll look at it from the lottery. Let's sort of look at it from the lottery person's point of view. The expected amount that they're going to win when you pay them $1 is $1. So they're expected to make $1. But if you win, they're going to lose some money. So 20% of the people get a free ticket, win a free ticket. that's worth $1. So that would be this minus 20%, a free ticket which is worth $1, so that's $1, minus 1% of the people are going to win $5, so they're going to lose 5 here. Then these other probabilities occur very rarely. So minus 0.0001, like this, times $1,000. I'm sorry, times $1,000, and then minus 0.000001 times $1 million. And so we calculate these, and I actually made a mistake up here on this one. It said 1 in 10 million. So coming back and doing that problem again, it's actually, I need one more zero, so it should be 0.1, 2, 3, 4, 5, 6, like this. So we need another 0 inside of here. Get rid of this, so this will be 0.1, 2, 3, 4, 5, 6, 1, like that. So we calculate that. We're going to get 0.2 times 1. So this will be 1 minus this right here is just 20 cents. Minus 0.01 times 5. This is just 5 cents. And this times 1,000 is just 1 cent. And then this times 1 million is 10 cents. So we can calculate this now by adding up these values back here. And this will be 1 minus 36 cents. And it's equal to 64 cents. So even though the lottery company may or may not pay somebody for winning, on every ticket they sell, they're expected to make 64 cents, which if you sell millions and millions of tickets, your profit is going to be very high based off of that. So this is what we call the expected value. And it's based off the law of large numbers. And the law of large numbers says that if you do something over and over again, what actually happens is going to approach what should happen, what could happen, or what should happen. So keep that in mind.